Let's start to talk about matter. Start by picturing in your mind a city street, any city street. How many things do you think it takes to make up that city street? If we look at matter, it really comes down to only three things. How can that be, you're probably asking? Well, everything we can see, feel, touch, and smell is made up of matter. Matter only comes in the forms found on the periodic table, 90 in nature, and we call those elements. Those elements are all made of only three things: protons, neutrons, and electrons. Let's start with the simplest atom that contains neutrons. It's number 2 on the periodic table. The first thing we find are two protons. Protons are found in the nucleus. They have a positive charge and they have a mass of 1. Next, we find two neutrons. They are also found in the nucleus. They have no charge, but they also have a mass of 1, just like protons. To finish our diagram, we add the electrons. Electrons move in orbits around the nucleus. For helium, there are only 2 electrons, and they belong in the first orbit. Electrons have a negative charge, and they have no mass. Let's look more closely at the protons. Again, protons are found in the nucleus, the center of the atom. The number of protons can never change. An atom is actually defined or identified by the number of protons. If the number of protons is changed, the element is changed, the atom is changed. Now let's look at the neutron, which is also found in the nucleus, the center of the atom. Neutrons have a mass of 1 and no charge. But in atoms, the number of neutrons is not always the same. The same atom can have different forms with different numbers of neutrons. These are called isotopes. And isotopes can be very important for research, medical treatment, and medical imaging. Because they are radioactive, they are easily to detect. Usually, the number of electrons in an atom is exactly equal to the number of protons, meaning there's no net charge. But sometimes the number of electrons change. An atom can gain or lose an electron. Then it would no longer be called an atom, but an ion, and would have a plus or minus charge. The rules for placing electrons around the nucleus in their particular levels is: level number 1 will hold a maximum of 2 electrons. Level number 2 will hold a maximum of 8 electrons. Level number 3, for all the things we use in biology, the maximum will be 8 electrons as well. Make sure you fill the layers in order, starting with level 1. And remember, the outside layer with an electron in it is called the valence. And the most stable outer layer, the most stable valence, is 8 electrons, except for hydrogen and helium, whose outside layer is level 1, and so for them it is only 2 electrons. The reason chemicals form bonds is because they are trying to make the most stable outer layer. 8 for most elements, 2 for hydrogen and helium.